congruence, side, 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 and side angle side. So this is going to be a shortcut for proving triangles congruence from the last lesson. Remember to take notes and do your check it outs.
We have one learning target today, and that is again just to prove triangles are congruent using the side, side, side theorem and the side angle side theorem. Or postulate.
All right, we only need to know that two triangles have three pairs of congruent corresponding sides. So this is our first postulate, side, side, side. So we don't have to know anything about the angles to know that the triangles are congruent. So it says if three sides of one triangle are congruent to three sides of another, the triangles are congruent. And here's an example. We can see a triangle with a 4 centimeter side, a 6 centimeter side, and a 7 centimeter side. And we have another one with those same three sides. Because we know the three sides are congruent, we can say triangle ABC is congruent to FDE. And remember, ABC tells us, being congruent to FDE tells us that angle A is congruent to angle F, angle B is congruent to angle D, and angle C is congruent to angle E. So remember, the order of the letters in your congruent statement is extremely important.
Okay, so here we want to use side, side, side to explain why triangle ABC is congruent to triangle DBC. Okay, so we're given that side AB, segment AB, is congruent to segment DB. So that's our statement here. And that segment AC is congruent to segment DC. And again, notice that the corresponding vertices are lining up based on how our triangles were named. And then we have this segment here in the middle, segment BC, is congruent to itself from reflexive property of congruence. So we have all three sides of the corresponding triangles being congruent, so we have these two triangles congruent using side, side, side.
All right, so now you are going to explain why you can use side, side, side to prove that triangle ABC is congruent to triangle CDA.
Okay, before we talk about our side angle side postulate, we need to define what an included angle is. It's an angle formed by two adjacent sides of a polygon. So we have angle B here. It's formed by segment AB and CB, which makes this the included angle between those two sides. So our postulate now is side angle side, and that's another way we can prove triangles are congruent. We have two sides of the triangle congruent, and the included angle, or the angle between the two sides, are congruent. Then our triangles will be congruent. So we have side AB is congruent to EF, and ED is congruent to AC, and this angle here, angle A, is congruent to angle E, and it's included between the two angles, or two sides. Therefore, our triangles are congruent.
All right, so this diagram has a tower that's made up of two triangles. We're going to use SAS side angle side to explain why triangle XYZ, so that's this triangle here, is congruent to triangle ZWV, or VWZ, sorry. All right, so I put up what they have given us, namely that XZ is congruent to VZ, so that's this one and this one, as well as YZ is congruent to VZ, so that's going to be this one and this one. And then the last thing we know is that
WZ.
W?
Right here. Yeah.
Thank you.
There you go.
There, is that better?
On our Veterans Day.
Okay. And then angle XZY, so XZY is this one, is going to be congruent to VZW, and that's this triangle here. So this one and this one, as well as YZ is congruent to VZ, so that's this triangle here. And then the last thing we know is that WZ is congruent to VZ, so that's going to be this one and this one. And then the last thing we know is that XY is this one, and YZ is congruent to VZ, so that's this triangle here. And then the last thing we know is that YZ is congruent to VZ, so that's this triangle here. And then the last thing we know is that YZ is congruent to VZ, so that's this triangle here. And then the last thing we know is that YZ is congruent to VZ, so that's this triangle here. And then the last thing we know is that YZ is congruent to VZ, so that's this triangle here. And then the last thing we know is that YZ is congruent to VZ, so that's this triangle here. And then the last thing we know is that YZ is congruent to VZ, so that's this triangle here. And then the last thing we know is that YZ is congruent to VZ, so that's this triangle here. And then the last thing we know is that YZ is congruent to VZ, so that's this triangle here. And then the last thing we know is that YZ is cong which is this one, because they are vertical angles. So I have my congruent marks there. And now we can say that triangle XYZ is congruent to VWZ by SAS.
When you're using these postulates, sometimes it's easy if you don't pick up your pen or your pencil when you're doing these. So to make sure it's include angle, we have a side, angle, side. So you know it's going to include an angle in there. And then again here we're going to have a side, angle, side. So that's a good way to check, or side, side, side. You don't lift up your pen or your pencil when you're marking them.
Nice tip.
Thanks. Oh, now it's your turn to explain why those two triangles are congruent using the side, angle, side postulate.
All right, so we're going to show that the triangles are congruent for the given value of the variable. So it tells us that x is equal to 5. Ooh, that's ugly. Ugly. Excuse me. I have to get rid of that. X is equal to 5. And we have the side lengths for this one. We don't for the second triangle, so we're going to plug x equal 5 into those expressions and see what we get. All right, so I plugged 5 into each expression, so QR was equal to 5. QP is equal to 5 plus 2, or 7. And RP is equal to 3 times 5 minus 9, or 6. And we can see our side lengths are 5, 7, 6, 5, 7, 6. So this is going to be congruent. So triangle M. So triangle MNO is congruent to triangle PQR by SSS side.
So now we want to show that triangle STU is congruent to triangle BWX when y is 4. Okay, so based on how our triangles were named, I went ahead and marked which would be the corresponding sides are, and then figured out the length for TU and y was 4. So TU is length 7, which is good because TU corresponds, supposed to be congruent to XW, so that works out great. Side ST, segment ST is 11, and ST is going to be congruent to BW, which is also 11. So again, we're doing good so far. And then we had to find our included angle here. And plugging in 4 for y, angle UTS equals 92, which can also match the angle for XYV, XWV. There's no y in this one. So by side, angle, side, those two triangles are congruent.
All right, so it's your turn to show that triangle ADB is congruent to triangle CDB when t is equal to 4. And make sure you include the theorem that you're using to prove congruence.
Okay, so here's a proof. Yay! I know you guys like these two common proofs. So we're given that segment BC is parallel to AD, and we have little parallel markings. Again, it's very important. You can't assume anything unless you're marked or given that information. So they're marked parallel, and we're given that they're parallel. And that segment BC is congruent to segment AD, and again we have the congruent little tick marks there. We want to prove that triangle ABD is congruent to triangle CDB. So this triangle is congruent. So we start with what we're given, that our two segments, segment BC was parallel to segment AD, and that was given. And now we have two parallel lines cut by a transversal. So those theorems aren't going away. There's our transversal, making the alternate interior angles congruent. So angle CBD, this angle here is congruent to angle ADB. We have those two angles are congruent. So again, these postulates and theorems can come back for the rest of the year. We're using our second given, segment BC is congruent to segment AD. And then we have what was our transversal. Segment BD is congruent to itself. That's our reflexive property. So now we have, looking at our picture we've got all marked up here, we can show the two triangles are congruent. We have a side, angle, side, and a side, angle, side. So using side, angle, side, we have our two angles congruent, our triangles congruent.
All right, so you get to write a proof for these two triangles. Make sure you start with what you're given, and you are trying to prove the triangle RQP is congruent to SQP.
Okay, so in today's lesson, we covered two postulates to prove triangles are congruent. First one is side, 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 and the other one was side, angle, side. And the order of the letters do matter, both in using either of these postulates. Again, you have to go sides, the three sides have to be congruent and corresponding in the same order. And the side, angle, side has to be the included angle, just as it says, has to go side, include angle on the side. But then when you're naming your polygon, or any of your polygons, make sure, write the one on the left and then list the corresponding ones on the right. That's the easiest way to start.
All right, so good luck, and we'll see you next time.